Okay, we're going to be talking about word problems now with a system of equations. We've done lots of word problems before that were like comparison problems where we just had one variable. Well, this time we're going to have two variables. And one clue that we have to have two variables a lot of times is that you're given two totals. So let's read this problem out loud. I'm thinking of two numbers. Their sum is 125 and their difference is 99. Find the numbers. So I'm given two totals, which means that I'm going to end up having to have two different equations. The other thing is that I don't have, I'm not saying the first number is 2 times the second number. So there's no comparison happening. So what I'm going to do for defining my variables, all I need to do is pick two variables. Oftentimes x and y are good variables to pick. So if I pick x and y, let's say that x just represents the first number and y represents the second number. And basically, because I've got two totals, their sum is 125, which basically means that these two numbers right here, if I add them together, it should give me 125. So I'm going to say x plus y equals 125. And then their difference is 99. Well, that's subtraction. If I subtract these two numbers, x minus y, I should get 99. So now in this one right here, we've got our choice. For your homework, you need to use every method at least once. So you have to use substitution at least once, you have to use elimination, or you have to use graphing. This one right here, super easy to use elimination, hands down. So if I don't have to move anything around, if I add, these guys are going to cancel out. You're going to get that 2x equals 125 plus 99 is going to give us 224. And then you're going to divide everything by 2. And we're going to get here that x is equal to 112. So x, we said was our first number. Well, that's 112. And so the other one, we know since we could plug into either equation, so I know that x plus y equals 125. So if I take 112, put it where the x is, add it to y, basically all I have to do to get y is subtract 112 from 125. And we then get y is equal to 13. So I'm going to put 13 up here. So now, real quick check, go ahead and add these two numbers together, and if they equal 125, we're good. So these two numbers added together should equal 125. If you subtract them, do they equal 99? And they sure do. Number 2. At McDonald's, a cheeseburger has 200 fewer calories than a large fries. 2 cheeseburgers and a large fries have 1,100 calories. How many calories are in each item? My advice to you at this point is to pause the video and see if you can just figure out what your two variables are. Okay, your two variables. Clue. You could at least get one of your variables by looking at the question, right? How many calories are in each item? Well, this one, it's asking for calories in each item. Well, what are our two items? Well, we have a cheeseburger for one. We have large fries for another. So calories in a cheeseburger would be 1. Calories in large fries would be another. Now you could use x and y again. I like to use letters that represent my items. So I'm going to say a burger. I'm going to call that B. And I'm going to use a big B. And I'm going to use F for fries. So my burger would be calories in a cheeseburger. I'm going to abbreviate cheeseburger. And F would be calories in a large fry. Those are my variables. Okay, so now I need to take each sentence one at a time. So I have to have two equations. The first one says a cheeseburger has 200 calories fewer than a large fry. Well, a cheeseburger, that's B. Has. The word has is implying that the burger is equal to something, right? So I'm going to put it over here. B equals 200 fewer than the large fries, which is going to give us the fries minus 200, right? Because the burger is going to be 200 fewer than the fries. So that's my first equation. The next one, the next sentence is going to give us my next equation. It says 2 cheeseburgers and a large fry have 1,100 calories. So 2 cheeseburgers, well, that would be 2B plus 1 large fry, so that would just be F, has to equal 1,100 calories. So now take a look at this problem. Would you use substitution or elimination? I, hands down for this one, would use substitution. Take a minute to solve it, then come back to see if you've got it. So to solve this one, I'm going to take that f minus 200, and I'm going to put it right where the b is, because I'm going to use substitution. So I'm going to do 2 parentheses f minus 200, close my parentheses, plus f equals 1100. Distribute. When I distribute, I'm going to get 2f minus 400 plus f equals 1100. Combine my like terms. Where did I get that crazy f there? 2f and f give me 3f minus 400 equals 1100. Then I'm going to add 400 to both sides. When I do that, that is going to give me 3f equals 1500. Divide everything by 3, and we get here now that f is equal to 500. So we're going to come back up here. Well, we know that f is 500 calories, so we know that fries have 500 calories. And to figure out what the burger is, well, we just have to put it up here. 500 minus 200 is 300. So burger is 300 calories. So these do not need to be written as ordered pairs because it doesn't matter what order they go in. You just have to say that, and you're done. All right, number 3. You have a choice of 2 different internet companies. Company A charges $12 per month plus $2 per hour. Company B charges $27 per month plus 50 cents per hour. When will both companies cost the same? Now, this problem is a little bit tricky because a lot of times people want to put your variables as A and B and say that A stands for company A and B stands for company B. But that's not the 2 things that we're missing. We have information about company A, charges $12 per month plus $2 per hour. We have information about company B. Charges $27 per month plus 50 cents per hour. And the question, when will both companies cost the same? Well, the cost per month is really going to be one of our variables. And so now think about it. To find the cost per month, we need to know how many hours you spend on the internet. So this question was written way back when you used to have to pay hourly for the internet. Crazy stuff. So let's say that X is hours. So I'm going to put over here, X is the number of hours we spend on the internet. If you know the number of hours that you spend on the internet, you can then figure out Y, which is going to be the total cost that the company is going to charge you, basically, for the month. So I would say total cost per month, if we want to be really specific. Okay, so what I'm going to do is I'm going to write an equation for company A and then a different equation for company B. So if you think about it, the cost per month is $12 plus $2 per hour. So I'm going to say Y is equal to, they charge you $12 no matter what, but then they charge you $2 for every hour that you are on the internet. So that's 12 plus 2x. And then the other company B is going to say, well, their total cost is calculated by doing 27. So they charge you more per month, but they only charge you 50 cents. So I'm going to say plus 0.5x per hour there. So this one, what I would do with this question, both of these equations are in slope-intercept form. They're both equal to y. So what I would do right now is go into your calculator, plug both of these in to y equals. Once that you have them in y equals, think about what you're going to pick. You're going to choose second calc, go down to intersect, see where they intersect, and if you can't see where they intersect, play around with your window so that you can see the intersection a little bit, and then get the answer. So if you need to pause the video here to get the answer, go ahead and do that. If you've got it, you should have gotten here that x is 10 and y is 32. So the solution is 10, 32. So now, what in the world does this solution mean? Well, we said that x was the number of hours, right? So we said 10 would be the number of hours, and y would be the total cost. So you got to keep in mind that this is the place where the lines intersected. This would be the place where, here, if we have two lines that intersected, that's the place, the 1032, that's the place where both the companies cost the same. So what does the solution mean? Well, this solution means that after 10 hours, both companies charge $32. All right, so that's how much they cost at the same time. 10 hours, $32. So now the question is, well, when would you choose company A and when would you choose company B? All right, so to be able to understand this question, you really need to have a better understanding, or a really good understanding of what the graph actually looks like. So I am going to go ahead and get rid of some stuff here and kind of give you an idea of what we're talking about. So I didn't draw a very accurate graph, so you guys can see it, but really what's important is just the first quadrant, right? So this company right here has a lower y-intercept, right? But its rise over run is much steeper. So it's going to be a line that's a little bit steeper, okay? Now this one, company B, had a higher monthly fee. So it started higher, and then it started higher, and it started higher, but its slope was 0.5 or 1/2, right? So then the place where they intersect, that's the place where both companies cost the same. So after 10 hours, it costs $32, right? So now look at what happens after that point right there. This right here was the one that had the lower y-intercept, but steeper slope. That's company A. And then this right here had the higher y-intercept. That's company B. So which company is going to be cheaper after 10 hours? Something tells me that most of y'all are going to choose company B because it's cheaper after 10 hours. The only reason anybody would choose company A is if they spend less than 10 hours a month on the internet. And this day and age, I'm pretty sure none of us do that. So company A would be the better choice if you spend more than 10 hours on the internet every month because it's cheaper after 10 hours. All right, question number 4. I challenge you for the next several. I would go ahead and see if you can set them up yourself. Tell me what method. You don't have to solve these. See if you can set them up by yourself and then come back and check to see if you've got them right. So let's go ahead and take number 4. There are 13 animals in a barn. Some are chickens, some are pigs. There are 40 legs in all. How many of each animal are there? Well, the question, how many of each animal are there? Well, there are your variables right there. We've got chickens and we've got pigs. I'm going to go ahead and use C and P. So I've got chickens is C and P is pigs. Now I'm talking about how many of each that I have, right? So we know I've got 13 animals in the barn and we have 40 legs in all. Let's go ahead and take 13 because that's pretty easy to deal with. We know that the number of chickens plus the number of pigs has to equal 13. 13 total animals. Well, then it says, well, there are 40 legs in all. Well, that's my other total. I got to get something that equals 40. If you think about it, how many legs do chickens have? They have 2 legs. So every chicken times 2 is going to give you how many legs you have on the chickens. And then pigs, they have 4 legs, so you're going to do plus 4p. That's got to equal 40. So the best method here, you have 2 choices. You have to do something for elimination and you have to do something for substitution. My favorite method is elimination. The reason I would use elimination is because it's already set up and all I have to do is multiply the top by -1. Or I'm sorry, by like -2 or -4. But you could also use substitution. This is sort of a preference of which method you like the best because substitution is pretty easy too because you've got a variable that's really easy to get alone. You could get the C alone or you could get the P alone. All right, next question. Okay, number 5. A class of 195 students went on a field trip. They took 7 vehicles, some cars and some buses. Find the number of cars and the number of buses they took. If each car holds 5 students and each bus holds 45 students. Well, the question, find the number of cars and the number of buses they took, gives us our variables, right? So I'm going to use C for number of cars we took. And B, I like to use big B so it doesn't look like a 6, for number of buses. All right, so now we've got lots of totals here, right? We have 195 students went on this field trip. They took 7 vehicles. And then I've got here that each car holds 5 students and each bus holds 45 students. Well, let's just think about our totals here. How would we get that? I think 7 is the easiest to start with. You know that the number of cars plus the number of buses equals 7. 7 total vehicles. Oops, let's make that a big B. Big ugly B. All right. Now, 195 students is your other total. You know that you have to come up with something that equals 195 students. Well, each car holds 5 students. So you're going to take the cars and multiply that by 5. That tells you how many students you have in the cars. And then each bus holds 45 students. So you just add 45B right there to get it. Again, this problem is just like number 6. I would use, for the same reasons I stated before, elimination or substitution. Either one. Whichever one you like. Okay, number 6 is one of my favorite problems. It's also a little tiny bit confusing. So, it says here, the larger of 2 numbers is 1 more than twice the smaller. So just notice right now, the first sentence used the word larger, and it's being compared to the smaller. The second sentence says the sum of the numbers is 20 less than 3 times the larger. Find the numbers. Well, our numbers, we don't here just want to say first number and second number because it's being very specific. Larger and smaller. So what I would do is call one of my variables the larger and one the smaller. Okay? So you know the difference between the two. So I'm going to go ahead and use x and y here again. So I'm going to say x is the smaller. And it does not matter which one you say is smaller and which one you say is larger. And I'm going to say y is the larger, okay? Now, if you did this problem already and you said x was the larger and y was the smaller, that's okay. The only difference between my equation and your equation is that the variables are going to be switched. If we solved them, we would both get the same answer, okay? So now, let's take the first sentence. A lot of you have trouble with these sentences. The larger of 2 numbers is. The word is where that equal sign goes. 1 more than twice the smaller. So the larger of 2 numbers is what you're going to write first. Well, which one is the larger? Oh, that's y. So I have y is. So that's where I put y is equal to 1 more than twice the smaller. Well, that would be 2x plus 1. 1 more than twice the smaller. 1 more than twice the smaller. That's your first equation. Now the second equation comes from the second sentence. It says that the sum of the numbers is, that's really important, the word is, because that's where the equal sign goes. So the sum of the numbers equals 20 less than 3 times the larger. So let's start with the sum of the numbers. Well, the sum of the numbers, that would be x plus y. You add the numbers together. Is, that's equal to 20 less than 3 times the smaller, or the larger. So 3 times the larger is y, so we're going to say 3y minus 20. 20 less than 3 times the larger. Okay? Now if you switched these two, and you said that x was larger and y was smaller, then you would just have x equals 2y plus 1, and you would have x plus y equals 3x minus 20. Either way, does not matter which one you called smaller and which one you called larger. When you go to solve it, the answer will speak for itself if you had to solve this one. So this one, hands down, the method I would use here is substitution. I would not mess with any other method here because, look, y is already alone. All you have to do is put y into the equation below, 2x plus 1, but you have to put it in 2 places. You'd have to put it here, and you'd have to put it here. Okay? All right, last but not least, the senior class at High School A and High School B planned separate trips to New York City. The senior class at High School A rented and filled 1 van and 6 buses with 372 students. High School B rented and filled 4 vans and 12 buses with 780 students. Each van and each bus carried the same number of students. How many students can a van carry? How many students can a bus carry? Okay, right there, those questions right there are going to give you your variables. I'm going to call V the number of students in a van. And I'm going to go ahead and call B the number of students in a bus. Okay? All right, so now we've got, you don't want to say that your variables are A and B because we've got an equation for school A and an equation for school B. So let's take an equation for school A. 1 van and 6 buses with 372 students. Well, there you go. V plus 6B equals 372. And the other one, 4 vans, 12 buses, 780 students. There you go. 4V plus 12B equals 780 students. Method I would use here. Because I like elimination, I personally would use elimination. What I would do is multiply the whole top equation by -4 to cancel out my V's, or you can multiply the whole top equation by -2 to cancel out your B's. You also, though, because that V is right there and all you'd have to do is subtract 6B from both sides to get it, you could also use substitution. Either one is really good. And you are finished. Now go ahead and try the rest of the packet on your own. Be sure that you use every method at least once. So you've got to get in elimination, substitution, and a graphing.